At this very moment, in labs scattered across 3 continents, astrophysicists are running simulations that rewind time itself. They're tracing 3E Atlas's path backward through the void of interstellar space, trying to uncover where this mysterious traveler came from. But what they've found doesn't just upend our ideas about how objects move through the galaxy. It hints at something far more unsettling, that its arrival in our solar system right now might not be a coincidence at all. I'm Mo Kaku, and as a theoretical physicist who has spent decades studying the cosmos, I can tell you this with absolute certainty. What we're witnessing with 3E Atlas represents either the most extraordinary coincidence in astronomical history, or evidence of something that forces us to fundamentally reconsider our place in the universe. Because when you actually calculate where this object came from, when you map its trajectory backward through hundreds of thousands of years of interstellar travel, the mathematics starts whispering something deeply unsettling. Let me take you through what we've discovered, because the implications become more terrifying with each layer we peel back. When 3E Atlas first entered our detection range in early 2025, astronomers immediately began the standard protocol for any interstellar visitor. They measured its velocity, calculated its trajectory, and attempted to determine its point of origin. This is fundamental astronomy. Every object in space carries a signature written in its motion, a vector pointing backward through time toward wherever it began its journey. For most comets originating within our solar system, this calculation is straightforward. They trace back to the Oort cloud or the Kuiper belt, predictable reservoirs of icy debris orbiting our sun. But 3E Atlas is different. Its hyperbolic trajectory immediately confirmed interstellar origins. It's moving too fast, arriving from the wrong angle, carrying a velocity that only makes sense if it originated beyond our sun's gravitational influence. So, the question became obvious: which star system did it come from? And here's where our first disturbing discovery emerged. The Harvard-Smithsonian Center for Astrophysics, working in collaboration with the European Southern Observatory, ran the trajectory calculations backward.
They accounted for the sun's gravity, the subtle gravitational perturbations from Jupiter and Saturn, even the minute effects of solar radiation pressure acting on the object over time. They rewound 3E Atlas through space, following its path like a cosmic detective, tracing footprints through fresh snow. The results pointed toward a region of space approximately 300 light-years distant in the direction of the constellation Ursa Major. But here's what troubled the researchers immediately. There are no significant stellar formations in that precise region. No bright, young stars that might be ejecting rocky debris through violent planetary formation. No supernova remnants that could fling material across interstellar distances. Just empty darkness, punctuated by a handful of dim red dwarfs, ancient, dying stars that haven't possessed enough energy to form planetary systems in billions of years. Dr. Sarah Chen at MIT's Kavli Institute put it bluntly in her preliminary report. We're looking at an origin point that makes no statistical sense. Natural ejection mechanisms require active stellar environments, violent events capable of accelerating material to escape velocity. What we're seeing here suggests either our models of stellar dynamics are fundamentally incomplete, or this object didn't originate naturally at all. But the mystery deepens considerably when you examine the trajectory more carefully, because 3E Atlas didn't travel in a straight line from that empty region of space to our solar system. The path curves subtly but measurably, and those curves appear at locations where massive gravitational influences from nearby stars should have altered the trajectory. It's as if something compensated for those gravitational perturbations, maintaining a course that conventional ballistic physics cannot explain.
Think about what this means for a moment. A natural object ejected from a star system billions of years ago would tumble chaotically through the galaxy, its path determined entirely by gravity and momentum. Every close encounter with a stellar mass would bend that trajectory slightly.
Over hundreds of thousands of years and hundreds of light-years of travel, these accumulated deflections would create a wandering path, essentially a drunkard's walk through the cosmos. But when we calculate what 3I Atlas's trajectory should look like if it were truly passive, if it were simply drifting ballistically through space, the predicted path doesn't match the observed path. The discrepancies are small, just a few degrees of arc spread across enormous distances, but they're statistically significant and they're consistent. The object appears to have maintained course corrections, subtle adjustments that kept it aimed not just toward our general region of the galaxy, but specifically toward our solar system. Avi Loeb has analyzed this data extensively, and his conclusion carries weight precisely because of his reputation for mathematical rigor. He calculates the probability of a natural object originating from that empty region, traveling for several 100,000 years, and arriving at our solar system along the observed trajectory by pure chance. The odds come out to approximately 1 in 50 million. Those aren't impossible odds, certainly, but they're profoundly suspicious odds. It's like shuffling a deck of cards and dealing yourself a royal flush 5 times consecutively. Possible, yes, but you'd be a fool not to suspect the deck was marked. Now, let's discuss the timing, because this is where the analysis becomes genuinely terrifying. 3I Atlas didn't just arrive at our solar system randomly. It arrived now, in 2025, at a moment in human civilization that represents something unprecedented in our 4-billion-year history. For the first time ever, humanity possesses technology sophisticated enough to detect interstellar visitors reliably. The Pan-STARRS telescope network that first spotted 3I Atlas only became operational in 2010. Before that, smaller interstellar objects would have passed through our system completely unnoticed, invisible to our primitive detection capabilities. We've only had eyes sensitive enough to see these visitors for approximately 15 years. That's a cosmic eye blink, a fraction of a percent of human history. And yet, within that narrow 15-year window, we've now detected 3 confirmed interstellar objects: Oumuamua in 2017, Borisov in 2019, and now 3I Atlas in 2025. If these objects were arriving randomly, distributed evenly across geological time, we would statistically expect to wait thousands of years between detections.
The concentration of arrivals precisely coinciding with our technological capability to observe them defies statistical expectation by orders of magnitude. Dr. James Wheeler at Caltech's Jet Propulsion Laboratory specializes in statistical mechanics and trajectory analysis. His team ran Monte Carlo simulations, generating millions of random scenarios for interstellar object arrival patterns across the past million years. In 99.97% of simulations, humanity would detect either 0 interstellar visitors or 1 at most during our current technological window. The probability of detecting 3 visitors within 8 years, arriving from different directions, displaying different characteristics, and each one pushing the boundaries of natural explanation progressively further, calculates at less than 1 in 100,000. Wheeler states it plainly in his unpublished analysis, which was leaked to several astronomy forums in early October. Either we're witnessing a statistical fluctuation so extreme it borders on miraculous, or there exists an unacknowledged correlation between our development of detection capability and the arrival of these objects. The second explanation, however uncomfortable, better fits the observational data. But there's another temporal element that makes this even more disturbing.
When researchers calculated exactly when 3I Atlas would have begun its journey toward our solar system, based on its velocity and distance traveled, they arrived at a time frame of approximately 200,000 to 300,000 years ago. That places the departure date within a fascinating window of human evolutionary history. Around 100,000 years ago, Homo sapiens had just emerged as a distinct species in Africa. We were beginning to develop symbolic thought, creating the first abstract art and inventing language complex enough to transmit cultural information across generations. We weren't yet technologically advanced, obviously, but we were becoming cognitively sophisticated enough to eventually develop technology. We were crossing the threshold from mere biological organisms into something capable of transforming our environment deliberately. Now, I want to be absolutely clear about something. I'm not suggesting that whoever or whatever might have dispatched 3I Atlas possessed prophetic abilities to predict human technological development 200,000 years in advance. That would be absurd. But consider this alternative interpretation. What if monitoring happens constantly? What if interstellar travelers are dispatched toward developing civilizations not as one-time missions, but as continuous surveillance? Send enough probes across enough time, and eventually some will arrive during the crucial window when a species becomes technologically detectable. This is precisely the strategy we ourselves would employ if we wanted to monitor the galaxy for emerging intelligence. You wouldn't wait for a civilization to develop and then begin your journey. Travel times are too long. By the time you arrived, the civilization might have destroyed itself, transcended physicality, or simply disappeared into irrelevance. Instead, you'd maintain a constant presence, a standing wave of observational missions cycling through potentially habitable star systems perpetually. And here's where the analysis of 3I Atlas's origin becomes most troubling. When astronomers map the region of space it apparently came from, they notice something peculiar about that empty zone in Ursa Major. It's not completely empty. There exists within that region a small cluster of brown dwarfs, failed stars that never accumulated enough mass to ignite fusion. These objects are extraordinarily difficult to detect because they emit almost no visible light. We've only cataloged them in recent years through infrared surveys and gravitational lensing observations. Brown dwarfs make terrible candidates for planetary systems under conventional understanding. They're too cool to sustain life-bearing planets, too unstable to maintain habitable zones. But they possess one interesting characteristic that's relevant to our discussion. They're nearly invisible. If you wanted to establish a presence in the galaxy while remaining undetected, if you wanted a base of operations from which to launch monitoring missions toward nearby star systems, a brown dwarf cluster would provide ideal camouflage. You'd be hidden in plain sight, occupying a region of space that conventional astronomical surveys would dismiss as uninteresting. Now, I must emphasize something crucial here. There exists absolutely no direct evidence of artificial structures or technological activity in that region. None. Zero. This is pure speculation, the kind of hypothesis that makes conservative astronomers understandably uncomfortable. But speculation serves a purpose in science. It generates testable predictions. It forces us to look more carefully at data we might otherwise dismiss. And the prediction here is straightforward. If 3I Atlas truly originated from that brown dwarf cluster, if it represents a deliberately dispatched probe rather than natural debris, then we should expect to see more visitors arriving from similar coordinates in the future. The arrival pattern would show directionality, a statistical clustering that natural distribution would not produce. Remarkably, preliminary data suggests exactly this pattern. When researchers examined the approximate origin vectors of Oumuamua, Borisov, and 3E Atlas, accounting for their different arrival times and the Sun's motion through the galaxy, they discovered something unexpected. All three objects trace back to regions within roughly 30 degrees of each other on the celestial sphere. That's a narrow arc, a focused stream rather than a random distribution from all directions. The probability of three random interstellar visitors arriving from such similar directions calculates at approximately 1 in 400. Not impossible, but deeply suspicious when combined with all the other statistical anomalies we've discussed. It's like watching three meteors streak across the sky in parallel paths. Technically possible if they're unrelated objects, but far more likely if they're fragments of the same parent body traveling together through space. Dr. Elizabeth Morrison at Oxford's Astrophysics Department published a controversial paper in September 2025 analyzing this clustering effect. Her conclusion generated significant backlash from the astronomical community, but her mathematics remains unassailable. The observed arrival pattern is 47 times more consistent with directed deployment than with random ejection from multiple stellar sources. While this does not constitute proof of artificial origin, it demands serious consideration rather than reflexive dismissal. But perhaps the most terrifying aspect of tracing 3E Atlas's origin isn't what we've discovered, it's what we haven't discovered. Despite intensive searches using radio telescopes, infrared surveys, and gravitational wave detectors, we've found no evidence whatsoever of the civilization that might have created this object.
No radio transmissions, no infrared signatures suggesting industrial heat waste, no obvious megastructures blocking starlight. Nothing but silence stretching across the vast distances. And that silence carries its own message. Because if 3I Atlas represents technology, if these interstellar visitors are manufactured artifacts, then whoever built them mastered capabilities far beyond our current understanding. They solved interstellar propulsion, possibly achieving velocities we consider theoretical. The engineered materials capable of surviving hundreds of thousands of years in the harsh environment of deep space. They developed power sources operating continuously across timescales that dwarf human civilization entirely. A society possessing such technology would likely appear to us the way we would appear to ancient Romans, not just advanced, but operating under principles so foreign, so unexpected, that recognizing their activities as technological might prove fundamentally impossible. We're searching for radio signals and industrial heat signatures because that's what our technology produces. But what if advanced civilizations transcend such crude energy expenditure? What if they manipulate space-time directly, operate on quantum scales we can't detect, or simply employ physics we haven't discovered yet? This is why the origin trace of 3I Atlas proves so unsettling. It points toward intelligence sophisticated enough to reach us, yet carefully hidden enough that we cannot reach back. It suggests observation without contact, monitoring without dialogue. And that asymmetry, that fundamental imbalance of awareness, represents perhaps the most psychologically disturbing revelation humanity could face. Throughout history, whenever one civilization encountered another with vastly superior technology, the less advanced society faced existential challenges to their worldview, their social structures, their very understanding of reality. The arrival of European ships fundamentally transformed civilizations that had never imagined such vessels possible.
Now imagine that dynamic scaled up to interstellar levels. We're not the explorers in this scenario. We're the inhabitants of an island watching lights on the horizon, realizing that ships are coming, but having no ability to determine their intentions, their origin, or their capabilities. On October 29, 2025, 3I Atlas will reach perihelion, its closest approach to our Sun. And according to analysis of its trajectory's origin point, this moment represents the optimal position for whatever comes next. Whether that's gravitational capture, probe deployment, or simply continued observation from a new vantage point, we cannot yet know. But the mathematics of where this object came from strongly suggests it didn't arrive here by accident. The universe has sent us a visitor, and when we traced that visitor back to its origins, we found nothing but darkness, statistical impossibilities, and implications that challenge everything we thought we understood about our cosmic solitude.